Hello, everyone, and welcome to Figuring Out What to Test. Let's talk about how to figure out what to test. Okay, so when you're analyzing code, trying to figure out how it works, what its test cases are. Well, my pad. I don't have any of my things. I'm not in my normal place. None of my stuff works like normal. There we go. All right, so what to test? The first thing that you want to look at when you're trying to figure out what to test, inputs. What does this thing take in? That starts giving that automatically cuts down the range of things that we could be passing into this from anything in the world to like these specific things in this specific order. That already narrows down what all this is quite a bit. Next thing to look at, what outputs does this thing have? Try to, like, it's not always immediately obvious, but try to make a guess at what the data type is. You might need to trace some inputs to your system to figure out what that is. But ultimately, that's the goal, is to figure out if I put these inputs into this black box, what outputs come out. That's the whole point of this. The tests give us confidence that we know which inputs turn into which outputs. Beyond that, some things that are kind of related. You want to check conditional logic. That's if, else if, else, switch, ternaries, short circuits. Anything that has branching logic probably needs a test case. Now, what gets really wild about this is that these are combinatorial. And so what that means is if you have one if statement and another if statement, those start multiplying on themselves. You might want to know, all right, I've got these two if statements. So that means it can go one of two different directions. Either the case is true or the case is false. The second one branches off of that. So that's first one is true, second one is false. First one is true and second one is true. First one is true and second one is false. First one is false, second one is true. First one is false, second one is false. If you have three instances of branching logic, you see how this starts getting kind of crazy pretty fast. This idea of all the possible branches through your code adding together has a huge vocabulary word. Cyclomatic complexity. We're not going to dig too deep on that, but the general idea is that how many different branches of logic there are in your code, that tends to compound and grow. And every one of those needs a test case if we're going to be confident that we know what this code does. So, branching logic, that's the thing to look at. A little bit less important than that. A lot of it less important than that, but something you should look at anyway. are anything that iterates. Just make sure that you're testing out any logic that iterates and making sure that it can actually do that iteration without falling apart. And so usually that means you're going back to the inputs, and if it takes in an array, does it work with an empty array? Does it work with an array with one thing? Does it work with an array with more than one thing? So all that stuff, I'm going to call that 3. And then last thing I'd recommend you take a look at, related to that, really kind of eats that up, I think, is equivalence partitions. Who's been reading ahead in the material and can tell me what an equivalence partition is?
It's where you go from like one result to the next.
That is an equivalence partition boundary. What is an equivalence partition itself?
One block where one thing is returned.
Yep. If something works with a 2-character string, probably works with a 3-character string and a 4-character string and a 500-character string and a 5,000,000-character string. We can treat all of those as effectively the same thing. That's called an equivalence partition. They also sometimes make sense in terms of like the actual logic of the code or what the problem is, where it might be like, I think there's a question in the equivalence partitions thing. It's like about drinking age. Okay, so equivalence partitions for that might be under 21 and over 21. 2 pretty reasonable partitions for that. The boundaries of those are where they change over. So like the boundary at turning 21, the day before you turn 21, the day after you turn 21, or I guess the day you turn 21. That's the most likely place you're going to see an error in like checking if someone's 21. Those should probably be checked. So maybe check at the boundary. Maybe if you're like a little nervous, you check somewhere inside the boundary also, but otherwise you can treat everything inside of a boundary kind of the same way. Okay, so that's our mental framework. We're going to like walk through some of these and then do them together, but these are the things that we're going to look at when we're trying to figure out what tests to write. Questions about this so far? Okay. So let's take a look at some code. I'm going to pull up the simple unit testing exercises, and maybe we can walk through a few of them together. All right, so, oh shoot, do I have sandbox set up for this? Nope, I don't. Never mind, I'm doing this locally. Oh, I don't want to go to file, I want to clone.
Hey, Kimmy, you're a lot angrier than our normal instructor. Just saying.
That's... I didn't get enough sleep last night. I'm having a hard day. I don't have any of my normal stuff. Alright, get clone. Alright, so I get this simple unit testing thing. If you have not done so already, why don't you pull this down too? I'll throw the link in chat for you. There's the repo. Hell, even if you're already working on this, you can clone it into another folder. Just go to somewhere that doesn't already have a folder called simple unit testing in it and run your git clone again. Run npm install to get the exercises or to get the dependencies. And let's get a little environment set up. So I generally like to do this with at least one process just watching the tests. Yeah, so like running npm test over here. Cool, and it didn't find any tests. So I've got one of those. I've got a place to add new tests and that kind of stuff, and something to actually write code in. So I want you to get as far as I am right now. Make sure this thing is cloned down. Make sure the dependencies are installed. Make sure you've got the test runner watching. And you've got this, this first one pulled up. Take a sec to get caught up. All right, give me a thumb scale. You ready to rock?
That's very slow. It's still trying the npm install. So.
All right, a couple of you ready to go. A couple of you not so much. So hey, how about this? How about we just wait a little bit? Always worth it. Make sure everybody's on the train before we leave the station.
After we do this one, I know you guys talked about number 3 a little bit yesterday.
Mm-hmm.
No, not yesterday, Friday. What am I saying? But I had a question about that one just after we do this one.
I think we'll get there. Love it. I can't remember if I found this the code gross or if I had to gross it up for like specifically the purpose of doing the modernizing. Oh, but it is gross.
Yeah, and that's kind of a problem with number 3. I don't think it works right.
It might
but
not.
It could just be me.
No, you do have to fix a couple things in the code to make it actually do the right thing.
Okay.
Yeah, I think
Versus,
it's
like,
this
result
It
dot
doesn't.
years of it should say years of experience spelled out.
Oh,
Otherwise, it's not
correct.
going to work.
Yeah, that should be that and that. Like I said, this is a new exercise, so we might find some of these things. All right, let's do a check-in on number 1. Thumb scale, ready to go. Loaded up, dependencies in. Sharon's good, Scott's good, Efren's good, Blair's good, Parnell's good. All right, Matt P's good. Let's rock. All right, so let's use the criteria that we were talking about. First thing, what are the inputs? What does this thing take in? So when I'm looking at this code, it says num, which I'm guessing could be a number, but you also still kind of need to look at how it's being used. Because is it a number that is actually a string, or who knows? One of these is these clever names are not awesome. So I'm comparing it to a number there. That gives me a pretty good hint that the inputs for this are going to be numbers. So I go, all right. On the input side, I've got a number. What's happening on the output side? So it looks like it's concatenating it with some stuff. It looks like that's some string. So the output is some kind of string. Next thing that I want to look at, conditional logic. How many pathways through this code are there? Well, if I screenshot this, let's trace all the different paths this code could take. A number comes in. We've got an if statement. So it could go here. That statement is true. It doesn't hit any of these other ones. So it end runs around to there. Next option. It go. Comes in through here, goes to there, ends up going to this, and then back out to there. Third thing, it's neither of those. So I can't see my... All right, so it comes in through there, ends up going to this else condition, and then out. So those are the 3 ways, 3 paths that the code could take. So that tells me there's at least 3 equivalence partitions that I should be looking at. So one of them is a number less than 5. So, hey, how about I check right at the boundary? I maybe want to check 4. And then this next one is the number is exactly 5. So then I want to check 5. And then otherwise, all right, well, what could otherwise be? Well, we could check right at the boundary again. 6. So it takes in a number. It has 3 possible ways to get through the code. And we've also managed to get all of the equivalence partitions on this. Because we have less than 5, we have more than 5, and then we have this whole boundary covered pretty damn well. So then, if we just walk through this code, so the number is 4. That means number is 4, result is an empty string. If num, which is 4, is less than 5. So is 4 less than 5? Yes, it is. So result becomes num plus that string. So now num is 4 is less than 5. And then we go all the way to the end. That's the output. So if we pass in 4, then the output should be 4 is less than 5. All right, well, what about if it's exactly 5? So it comes in there. Otherwise, the exact same logic. It's 5 is equal to 5. And otherwise, whatever it is greater than 5. Oh, and those all have periods too. So this should be 6 is greater than 5. Cool. So that's the input-output table. That's the process of showing how we figure out what we want to test on that. Questions so far?
I have a question.
Yeah.
When it comes to like testing stuff, like we've deduced that the number when the function was created is supposed to be number. Well,
Right.
num should be a number.
Correct.
But like when testing, I guess this falls under the part of like meaningful tests. Like, what if you wanted to test if a string is
Sure.
passed in the function? Is
Awesome.
that not meaningful? Because I mean,
So it depends. In a TypeScript world, no, that's not a meaningful test because it's not possible to pass anything other than a number into something that's expecting a number. In the JavaScript world, though, there's 2 schools of thought, and both of them are completely valid. One school of thought is that it's not any function's job to make sure that it was given legal values. It's whoever called its job. So, like, if I have a function that's calling check5, I want to check that whatever it's passing in is a number before I pass that in to check5. But check5 shouldn't be inspecting that and testing for it itself. That's one school of thought. The other one is that functions should be very generous and grateful in what they accept. And so what you would expect here is like, all right, if I pass in a string, can I coerce it to a number? Maybe I try to do that first. And then maybe I'm doing all like 4, 5, and 6 as strings also, because now those are also legal inputs. Or what if I pass something in that's completely batshit, like null or an empty array or something like that? So you could treat all of those as one equivalence partition where you just check to make sure that the type is a number first, and then everything gets like the same error otherwise. So in that case, you don't need to check every possible thing it couldn't be. You can just verify that if it's not a number, then it gets kicked back. And maybe 1 test case is good enough for that, or 2 test cases or something like that.
okay, and that makes more sense like when you're doing your actual code, not an example like this where it's just like a
Bingo.
exercise. Okay.
Right. And even still, it doesn't necessarily need to be gracefully handled. It just needs to be whatever you're expecting it to be. If you pass this an empty array, it's going to break your code. Is that okay? Like, if that's what you're expecting it to do, because you're confident you will never pass it an empty array, awesome. Move on with your life.
Okay, thank you.
And like, there's a thing that, I mean, I certainly fell into this. I think most people do when they're starting out with testing. It's really tempting to try to turn this into a math proof where it's impossible to have an illegal value come out of this. That's almost never worth it. What you're going for is enough confidence that this does what you think it does. Past that point, I think you probably have better uses of your time than making sure that if somebody passes something at the highest end of the integer boundary in JavaScript, that it gets the correct error when it tries to compare it. Like that kind of stuff, probably not worth the effort.
Okay, thank you.
Yeah, and if I were writing tests for this function, I would probably just do those 3 test cases. So let's do those 3 test cases. So if I make a tests 1.spec.js. It could also be 1.test.js. They're the same thing as far as jest is concerned. So I make one of those, 1spec.js. To actually write out this IO table as tests, first thing I need to do is import the function. So that's being exported with CommonJS. So I can import it as, what's it called, check5. Something like that. And then I can say test check5 correctly returns less than when given a number lower than 5. And one of your guest speakers mentioned this, but the first thing I'll do, I'll write out just the names of these test cases first. Runs equal to, when given a number, when given 5. And this one is okay. So I have these three test cases here. I'm going to skip these until I actually write out the stuff, and then otherwise I'm going to make sure that these are showing up over here. All right, cool. So I've got a green test because it's not doing anything. Something that doesn't do anything, doesn't throw any errors, it shows up as a green test. And now I need to pass 4 into check5 and then assert that this is the thing that happens when it comes back. So if I say like expect check5 4, so there's the input, to be four is less than 5. And I want to see it fail at least once. All right, cool. So I see it fail. No false positives. I fix that. It's green again. That gives me confidence that it does something right. If I put similar ones in here for these two, unskip the tests. Expect 5, expect 6. This should be, well, let's see that they fail. All right, I've got two failed tests. So I can say 5 is equal to 5. 6 is greater than 5. Six is greater than 5. And now I have passing tests. That's the process of translating your IO table into tests. Questions about this part?
This is just a small question.
Mm-hmm.
So in this case, we're doing it a little bit different than we were in the past, where we were like putting everything as variables first, like
Mm-hmm.
const integer equals
Yeah.
4, const blah blah blah. Which way do you prefer? Like,
If it's literally this, I'd probably write it this way. If it was much more complicated than that, I might try to save it in a variable first. But like, let's say I wrote this out the way that we were doing that before. Like, it might be input number equals 4, result equals check 5 with input number. You could even do this all the way and say like expected output is 4 is less than 5. We get the result there. So this is a real like arrange, act. Let me say like expect result to be expected output. So that's like a hardcore AAA way to do this. Is this more clear and like easy to follow and documentable than like that is? Like, I don't think so. Like this probably reads a little bit more like a sentence. Expect check 5 being past 4 to be 4 is less than 5. It's supposed to read like a regular English sentence. So I think that's probably a little easier to follow than that is. You'll see it both ways out in the wild, though. And the testing framework does not give a shit. This is just for you and the people you work with.
I know you said it doesn't really matter whether you do it as like individual tests like this or if you group it all into a described block.
Yeah.
Is there, kind of out in the wild, is there one that's more common than the other, one that we might run into more often?
No, I'd say every possible way that I outlined in like those test organization strategies are like equally common. So this one I think is a little bit popular right now because it's super easy to follow. It's flat. Kent C. Dodds, who is like very popular in the testing world right now, is like advocating for this pretty hard. In this particular situation, I'd probably go with describe it. So I might say describe check 5. Put all of these in here. Change them to its. And delete the check 5. Also still reads like English sentences, like probably even more so. Describe check 5. Well, it correctly returns less than when given a number lower than 5. It correctly returns equal to, so, and also like, I think makes your test output read a little bit better. Because these are like facts that you're trying to assert about check 5, and then the check mark or cross says whether or not the fact you're stating is true or not. I like that. The problem with doing it this way is it gets real tempting to put a bunch of before eaches and have like a really nested hierarchy that is very dry and doesn't have any repeats and any of that kind of stuff. And it just makes your tests harder to read. Writing them all flat as tests, like, kind of takes that tool out of the toolbox. But both of them wildly common.
So Don Hager, in his video for that first one, said to start it with a describe and start it with your it, that it should be defined. Should we do that? Or
no, I like that. So that's helpful. That's a little bit less helpful, like in this particular case. What John's trying to like coach you toward is TDD. So TDD is none of this exists. In fact, even this doesn't exist. File's not even there. And so, if I take a look at the test, it goes, check 5 is not a function. So if I do the absolute smallest thing that I can, it would be make that a function. And so if I say, maybe skip these, or rather, what if I do So I can go, I expect check 5 to be truthy. It says check 5 is not a function. Okay, well, what if I... Sorry, this is going to be it only. Oop, coming back with something. Why is that coming back with something? Okay, that's one of the reasons that we want to falsify these things.
Is it because you're missing the parentheses after check 5? If it's a function.
No, because I don't want to invoke it. I want to look at the actual value. Oh, maybe it. Oh, I know why. It's because it. It's an empty export. So an empty export is an object. So let's see. Let me look up the matcher for function. Just matchers. To be defined. Let's try that one. Nope. Let's see if I can assert its type. Maybe to be instance of. Yeah, I'll bet it's that. To be instance of function. Maybe capital F function. Yeah, there we go. Expect a constructor function got back object because it's an empty object. Also, I don't know if like everybody's put this together. You can still console log stuff in tests. I could say, what is check 5? And then it shows me the empty object up there. Tell me that it logged it. Okay, so it's expecting that that's a function. Well, it's not. So the bare minimum that I could do to make that pass the test is probably that. And now it's passing. And so then I go, okay, well, what about the next test? So that works. What about that one? Ah, but now it's returning undefined instead of 4 is less than 5. And you can actually play like this really coy game where you just try to fake that out. All right, I got a passing test just by hard coding that entire response. I can say, all right, what about the first 3? Ah, but it doesn't work on the second one because I hard coded the thing. And so like you can use this process to like slow roll as much as possible like what the logic of this is. And so that's what John is kind of nudging you toward. But it's mostly used in TDD, not just writing tests generally. Great question. What else? Okay, let's walk through the steps on this again. When we're trying to figure out what code does, first thing we look at is the inputs. Second thing we look at is the outputs. Got to figure out what those are. What are the types at a minimum? Because that's what we're testing. Do the inputs turn into the outputs that we think they do? We need to look at any conditional logic. That's different branches that the code could take. Each one of those is going to need at least one test. And then we want to check equivalence partitions and boundaries. So is there stuff that we have to loop through? Do we need to check if people are over or under 21? Does it take strings? Can it take an empty string? Can it take a string with some stuff in it? Does it take a function? What kinds of functions does it take? So those kinds of things are part of your equivalence partition and boundaries. Once you've figured out that stuff, we want to come up with examples. What are some examples of the inputs that exercise all these conditional branches? If we walk through those in the code, what do we think the logic should be? Once we have this I/O table, we just write the I/O table as tests. Use that to verify the behavior of the code. And then the last step of this for the assignment is, I see fields of green. So now I just need to keep this green while refactoring these. So I'm supposed to go with more modern syntax. I could do something like, let's see, how might I do this better? Could say if, first I'm going to change it to number, use the whole word. If number equals 5, return 5 is less than 5. So now I don't need that case. Now that I have just an if else, I can probably ternary that. So I can say return number is less than 5. And if that's true, then make that a template string. Put the number in, get rid of all that. Maybe something kind of like that. All right, am I still green? Nope.
Your first statement should be 5 is equal to 5.
There we go. See, and the test caught it too. And now I'm green again. So I totally changed the implementation of the code. You see how wild that was? Used to look like that. And when it did, I had green tests. And then I did a wildly different implementation. Still have green tests. That's the purpose of these. It caught that I got the is equal to wrong. Confidence. This makes it so that you don't run into the situation where you go, oh, I'm done with my project, and I kick back your stuff and go, change some of your code. You go, but I don't want it. I just got it working. I'm so scared it's going to break again. This tries to insulate us from that a little bit. Questions about this process? Bonus points. Anybody who's in the short circuiting lesson, how could I rewrite that as a short circuit?
You did the number and 5.
Like that?
Now, on the if number equals 5, if you did the number and maybe.
Like that, you mean?
I'm guessing. I don't know.
So this says if this is any truthy value, and if the number 5 is a truthy value, then do this. Not quite. I could do number is 5 and if that turns out to be true, actually, I don't know if it'll let me do a return statement here. Maybe. Let's see. Yeah, it's because I tried to do this inside of an expression. Never mind. Maybe that is a better way to do it. Cool. Let's do one together. All right, so let's jump to number 3 since Blair was asking about it.
To be fair, we did fix what I saw as the issue because it didn't work. But yeah.
All right, fine. Fuck number 3. Let's look at number 4.
Well, whatever number you want, don't just do it for that because it got fixed.
All right. So let's take a look at number 4. This is a great one. Because there's a bunch going on here. All right, so I want you to take some time, see if you can apply this process that we talked about. Think about the inputs. Think about the outputs. Thinking about the branches of logic. Thinking about what the equivalence partitions are. Can you come up with an input list? When you've come up with the input list, can you create an output list for that? Once you've created an input list and an output list, can you write them out as code? Let's give it a shot. We'll only take 10 minutes on this. Go! Even if you've done the assignment before, do it all over again. By the way, I have an inbox prompt out. Anytime you're done with your tests, go ahead and post what you got. Otherwise, 4 more minutes. Another minute and a half. All right, pencils down. Even if you did not finish, send me what you got. Let me see. Let me take a look at what we got going on. All right, I only got 3 of them. Send them in.
I just sent you mine. I just realized I didn't update my description on my tests, but I got the test in there.
All right. Not bloody bad, gang. Still
I
only
just
have 4.
realized I didn't change the on my my last 2 it statements. I didn't change it to the 0.05 and 0.08, so I've updated that.
It's all good. Send me what you got. All right. I still only see these 4, but whatever. Moving on with our lives. Let's walk through the approach on this. So, inputs on this one, kind of a lot of them. We've got salary. Tablet back. Come on. They wouldn't let me draw. Oh man, this is driving me crazy. I want to annotate the document. Come on, man. All right, fine. Okay, so I've got salary. Which is, looks to be a number. I have a tax code, which, let's take a look at every place that's being used in here. It can be 1150L, ST, or some other string. We have income tax 1. And if we look at where that's getting used, just used to make the total income tax. So, after number, that's a number. And then owns car, which isn't used anywhere. So we can disregard it. That's handy. All right, so those are our inputs. If we look at our conditions, it's really just all based around that tax code. So we need to make sure that we get those 4, or these 3 cases accounted for. And then we might want to check that with different combinations of these. So salary and income tax. We need to start like doing some interpreting on this. Can salaries be less than 0? Not really. Can salaries be 0? Yeah. All right. So like 0 is valid for that. So if I'm thinking of equivalence partitions I might want to test, 0 sort of makes sense. Greater than 0 kind of makes sense. All right, what are these deductions? So we have this national insurance thing on there. Really, the only thing I can imagine that affecting is either 0 or not 0. Other than that, I think that's kind of fine all around. So 0 or greater than 0. And then the income taxes, kind of the same thing. We might say that like your income tax was negative. So maybe we check for both of those. But they only get used to add up to like total income tax together. So we want to see that like in combination they hit our equivalence partition. But otherwise, maybe we don't sweat it so much. So we want those two things that are less than 0, 0, and greater than 0. So here's where this gets tricky. And this, like, admittedly, this is some try-hard shit. I might, like, roll my eyes pretty hard if I saw somebody do this in an actual code base. But this is the implication of this. We want to check these combinations. So you want to check a 0 salary with this tax code and a total income tax less than 0. And then a 0 income tax and this tax code and an income tax of 0. And then you want to tax a salary of 0 and that tax code and an income tax greater than 0. So let's see what that would look like in actual like test cases. Man, this is really hard to do.
Kind of a question, and I think Parnell actually hit on this a little earlier. Some of this code, obviously, you can kind of look at it and see that it doesn't do what it wants to do, or something like this, where I think at one point they take minus for student loans. So if you have a number that's less than that, you're going to get something next to negative. Do you want us to fix those as a part of this assignment, or just kind of go with it? Because
put it in the "this seems broken" channel.
Okay.
Because it might be broken. All right, so our potential test cases on this. So that's input, that's output. So we need a salary of 0, tax code of 1150L, and an income tax of, let's say, negative 1,000. Then we want that same thing with 0, and that same thing with something more than 0. So then we do the same thing with salaries that are greater than 0. So maybe that salary is 1,000, 1150L, negative 1,000. 0, 1,000. Cool. And so that gets us through 1150L. Then we'd be doing that same thing with ST. And then we'd be doing that same thing for something that is just a different tax code. So that ends up with 18 different test cases to comprehensively test this function. And then you would walk through what each of those boil out to, figure out the output, and then, hey, there's our tests. So in practice, would I write 18 test cases for this? Probably not. What I might do is look at some likely ones. Or, I don't know, maybe this is for a space shuttle launch, and maybe I want to test the living shit out of it, and every possible combination of legal pathways to the code, I want to make sure they're tested. Both of those are completely reasonable. Questions? Figure out what it's looking for. Then we got to figure out what the outputs kind of look like. We got to figure out, hey, conditions. Given these inputs, with these conditions, we expect to find out this answer. It's problem solving. Turn it into an I/O table. Use your inputs that you figured out that hit your partitions and boundaries and logic branches and stuff. Figure out what outputs they should make. Write those out. If we do all of this before we've written a single line of code, we call that test-driven development. That's what your company does. Figure out all these test cases first. And that gives us actually like a pretty good head start on what the logic for the code should be. And if we have these test cases and we can get them to pass with the dirtiest, gnarliest, shittiest code we could possibly write, when we have passing tests, it's always easier to keep code working while making it better than it is to take code from not working to working. So now our clean, elegant solution that would have been very difficult to come up with the first time, we now have like a test harness around us that allows us to like safely experiment and try stuff and know exactly when we broke something. We've seen that even with a pretty small function, the whole thing is 30 lines long or whatever. Having a whole lot of inputs turns into cyclomatic complexity nightmare very quickly. It's one of the reasons you don't want to have functions that take in a bajillion parameters. Last questions before we bounce. All right, friends. I hope that helped. Go learn something.
You.